Hi friends, in this video we will go through the lines of NCERT Class 9 Science Chapter 10 Gravitation Subtopic 10.1. In chapters 8 and 9 we have learned about the motion of objects and force as the cause of motion. We have learned that a force is needed to change the speed or the direction of an object. We always observe that an object dropped from a height falls towards the earth. We know that all the planets go around the sun. The moon goes around the earth. In all these cases, there must be some force acting on the objects, the planets, and on the moon. Isaac Newton could grasp that the same force is responsible for all these. This force is called gravitational force. In this chapter, we shall learn about gravitation and the Universal Law of Gravitation. We shall discuss the motion of objects under the influence of gravitational force on Earth. We shall study how the weight of a body varies from place to place. We shall also discuss the conditions for objects to float on liquids. 10.1 Gravitation. We know that the moon goes around the earth. An object when thrown upwards reaches a certain height and then falls downwards. It is said that when Newton was sitting under a tree, an apple fell on him. The fall of the apple made Newton start thinking. He thought that if the earth can attract an apple, can it not attract the moon? Is the force the same in both cases? He conjectured that the same type of force is responsible in both the cases. He argued that at each point of its orbit, the moon falls towards the earth instead of going off in a straight line. So, it must be attracted by the earth. But we do not really see the moon falling towards the earth. Let us try to understand the motion of the moon by recalling activity 8.11. Activity 10.1. Take a piece of thread. Tie a small stone at one end and hold the other end of the thread and whirl it around, as shown in figure 10.1. Note the motion of the stone. Release the thread. Again, note the direction of motion of the stone. Before the thread is released, the stone moves in a circular path with a certain speed and changes direction at every point. The change in direction involves change in velocity or acceleration. The force that causes this acceleration and keeps the body moving along the circular path is acting towards the center. The force is called Centripetal Force, meaning center-seeking force. In the absence of this force, the stone flies off along a straight line. This straight line will be a tangent to the circular path. More to know, a straight line that meets the circle at one and only point is called a tangent to the circle. Straight line ABC is a tangent to the circle at point B. The motion of the moon around the earth is due to the centripetal force. The centripetal force is provided by the force of attraction of the earth. If there was no such force, the moon would pursue a uniform straight line motion. It is seen that a falling apple is attracted towards the earth. Does the apple attract the earth? If so, we do not see the earth moving towards the apple. Why? According to the third law of motion, the apple does not attract the earth. But according to the second law of motion, for a given force, acceleration is inversely proportional to the mass of the object. The mass of an apple is negligibly small compared to that of the earth. So, we do not see the earth moving towards the apple. Extend the same argument for why the earth does not move towards the moon. In our solar system, all the planets go around the sun. By arguing the same way, we can say that there exists a force between the sun and the planets. From the above facts, Newton concluded that not only does the earth attract an apple and the moon, but all the objects in the universe attract each other. This force of attraction between objects is called gravitational force. 10.1.1 Universal Law of Gravitation. Every object in the universe attracts every other object with a force which is proportional to the product of their masses and inversely proportional to the square of the distance between them. The force is along the line joining the centers of the two objects. F is equal to m by d square. Let two objects A and B of masses m and m lie at a distance d from each other as shown in the figure. Let the force of attraction between two objects be F. According to the universal law of gravitation, the force between two objects is directly proportional to the product of their masses. That is, F is directly proportional to m into m. And the force between the two objects is inversely proportional to the square of the distance between them. That is, F is inversely proportional to d square. Combining both the equations, we get F is proportional to m by d square, or F is equal to g m by d square, where g is the constant of proportionality and is called the universal gravitation constant. By multiplying crosswise, equation 10.4 gives F d square is equal to g m, or g is equal to F d square by mm. The SI unit of g can be obtained by substituting the units of force, distance and mass in equation 10.5 as Newton meter square per kilogram square. The value of g was found out by Henry by using a sensitive balance. The accepted value of g is 6.673 into 10 raised to minus 11 Newton meter square per kilogram square. We know that there exists a force of attraction between any two objects. Compute the value of this force between you and your friend sitting close by. Conclude how you do not experience this force. The law is universal in the sense that it is applicable to all bodies, whether the bodies are big or small, whether they are celestial or terrestrial. Inverse square. Saying that F is inversely proportional to the square of D means, for example, that if D gets bigger by a factor of 6, F becomes 1 by 36 times smaller. The example questions and the in-text questions will be discussed in a video separately.